Hello and welcome to Not Out of Spec Dave. What the heck? I have taken over my dad's YouTube channel here in Germany because batteries. My dad needs to learn about electric car batteries, as do I, as do you. And so CATL actually kindly invited the Out of Spec Dave YouTube channel to explore their booth specifically. And that is why I am here to present to my dad's viewers all about the newest electric car battery, some new technology. We're talking crazy charging performance up to 12C. I'll explain what that means, all the way to really cold temperatures as well. And we're also going to be discussing the round trip recycling trip that a battery can take, all with CATL at the IAA Motor Show in Munich. As you know, I review electric cars. My dad plays around with electric cars and takes you on his road trips. We really want to learn more about the battery technology, about chemistry inside of the cars. And well, that's where CATL said, hey, we can provide some technical knowledge and some of our experience to share with your viewers. We thought that seems like a very harmonious relationship. Is that the correct word, Scott? Harmonious? Yeah, sounds good. We jive, I guess you could say. Should I just move on? Yes. CATL, world's leading supplier of electric car batteries. Did you know 1 in 3 electric cars are powered by CATL batteries? We will have the opportunity today to meet with one of the technical experts on the new Shenxing Pro battery pack, which is going to be, I think, the new standard for batteries in electric cars. We're talking 12C charging, which could enable, 1.2 megawatt charging on a 100 kilowatt hour battery pack, which is insane. Also with extreme durability, they're saying that they can warranty these cells with a little bit less charging performance. We'll have to ask the engineer, but for 1,000,000 kilometers or 12 years, still retaining 70% capacity. And we've seen consistently over the years, you guys will agree with me, when an automaker claims like a warrantyable mileage where they're like, it's 100,000 miles up to 70% capacity, like batteries don't degrade as quickly as people think. And what's crazy to me is we're seeing the charging performance go crazy and the degradation performance not drop off a cliff. In fact, some of the highest degradation performance that I've seen, just anecdotally, have been from cars that have almost unimpressive charging performance. So I'd love to ask one of the technical engineers more about that. Let me briefly take you around what we're able to look at here at the CATL booth. The first is going to be the Shenxing Pro. Obviously, they know we love super fast charging at Out of Spec, and so like, we got the guy to tell you all about that. And I'm like, I want to do 12C charging everywhere. So we are going to dig into that. By the way, what is C rate? C rate is essentially boiled down for the average, consumable information. You can take your kilowatt hour rate of the battery pack, 100 kilowatt hour. If it can charge at 100 kilowatts, that's 1C. It's basically 1 hour, 0 to full. Now, of course, there are curves and everything in between, but if you have a 12C charging peak rate, that's essentially 100 kilowatt hours, 12 times up, which would be 1.2 megawatts. That's the idea behind C rate. Come on over, I'll show you what else the booth has. Tons of people here at the IAA exhibition, which of course CATL really pushing the European automakers to have some amazing charging performance. We've seen a lot of Chinese cars recently come with 4C, 5C charging batteries. That is increasing so fast. 5C is going to seem old school in the future. And CATL has a partnership with every leading automaker, essentially, to provide batteries. Teslas have them, BMW, Mercedes, Smart, the list goes on and on. Different models have different sourcing. But again, in Europe, CATL is a huge player. And Europe's an interesting market for batteries because you have to charge them in extreme hot temperatures in southern Europe and extreme cold temperatures all the way up in northern Norway, and that's where this battery comes in. This is the CATL Naxtra battery, incredibly safe battery pack, and can also work basically down to negative 40 degrees Celsius without much power reduction. So that's a really huge benefit to having this type of chemistry. I want to learn more about this as well. And then we're going to work our way down this way throughout the CATL booth. It's always hard to show battery cells because what we're talking about is essentially the active material inside of the cell itself. Yes, there's some benefits to having a slightly different cell shape, and they have this new wave design. They have new prototype technology that's combining NMC and LFP essentially into one battery pack, split into two, which is a really interesting thing. So you get the durability and the charging 100% charging of LFP, but then also the huge discharge rate of NMC. Really cool. I don't honestly know how this works. We're going to dig into this into the future because you essentially have two battery packs that you have to manage in one. And this is becoming a new trend that we're seeing automakers get interested in as well. And another thing that we're going to discuss throughout this video is essentially the round trip economy of a battery pack from production to recycling. And within just 20 years from now or so, they believe that 50% of all new battery manufacturing can be sourced by recycled materials from what's already out there. So, what's nice is when you make a NMC battery, for example, you can have like 99.6% of nickel, manganese, and cobalt can be recycled, recaptured. And as long as there's a process, there's factories to do this, to get all the raw material out, you can give them a new life and you don't have to mine constantly. And yes, the need for batteries will expand into the future, and there's a never-ending desire to have more and more and more energy capacity output. But if you can supplement that new generation with as much recycling as possible, well, that's super important. So CATL is doing a ton of work in the round trip of battery packs, which I'm fascinated with and excited by. What I think we should dig into first is the Shenxing Pro with the insane charging performance. So we will meet with one of the engineers in the next clip, and I've got a lot of questions. Guys, you join me with one of the engineers of Shenxing Pro. This is Tao. How's it going?
Yeah, everything is fine.
It's been one heck of a show. You've been talking to so many people.
Yeah.
It's been crazy.
But yeah, to introduce our product, I'm so happy.
Yeah, amazing to hear.
Excited.
Great. So tell us a little bit about it, because we love electric cars on this channel. We love charging fast.
Yes.
We love charging in cold weather. We love durability. These are all things that our audience are looking for in their next electric car. Mm-hmm. So tell us a little bit about this new generation of battery.
Yes. As you know, we have several brands from our company introduced to the market for our customer. Qilin, Shenxing, and also next sodium battery.
Yeah.
This is our latest battery we published 2 days ago in Munich for Europe market, and this product belongs to our Shenxing family. And all the performance definition is focused on your requirement for the low temperature, fast charging, long life, high safety. Yes.
Yeah, and these are also important. So maybe just quickly, you can help us understand the benefits of the Qilin versus the Nextra versus the Shenxing, because I think we're pretty familiar with the Qilin battery. We've driven cars with this one. Great charging performance, 4 or 5C already in production. Very nice one. So what is each battery type typically used for?
Okay. Yeah, main difference is the chemistry. For Qilin, we normally apply NCM. Mm-hmm. For Nextra, we normally use sodium.
Oh, okay.
And for Shenxing family, we use LFP.
Okay,
yeah.
Nice. And LFP is becoming way more popular, especially in the US market and also in Europe.
Yes.
We like LFP because they seem to be a little bit more durable. Like you can really charge the cells, you can do what you want with them. Originally, LFP were always the slow charging ones. Now they're the fast charging ones.
Yes.
How did that happen?
Yes, for fast charging, we optimize a lot of things. One important thing is we optimize our chemistry. For example, we use the superconductivity electrolyte to optimize the lithium-ion interaction rate, speed, to make sure we can achieve the high super fast charging and high charging rate.
So what is the communicated charging rate of this? Is it 12C, I heard?
Yeah, the peak charging power is 12C.
Yeah.
And the average performance we can achieve from room temperature, it means 25 degrees.
Yeah.
We can achieve from 10 to 80%. In 10 minutes, we can achieve the driving range from to maximum to around 420 kilometers.
Right, and that of course depends on the car and the battery that you put in that car, but that's a really amazing amount of range.
Yeah, for the driving range calculation, we benchmark, for example, several similar vehicles to calculate the energy consumption.
Sure.
To estimate or predict the driving range is our battery.
Yeah, of course. And so the cells themselves, these are them right here. These are the 12C charging LFP cells.
Yes.
And I've noticed they're in this sort of wave formation, so-called. That's how you guys describe them.
Yes.
Can you tell us a little bit about the wave?
Yes, yes, this is our wave cell. As you mentioned, the wave cell, why we call it wave cell is the format like a wave. There is a shape like that. We lower down the terminal side.
Yeah.
And also on the shooter side, we make it.
Yeah.
On the shooter side, we make it flight.
Yeah.
And in this case, we can use inner space as much as we can. And also, we can make sure the electric gap between the bus bar and also the battery system top cover.
Yeah.
In that case, we can improve our volume energy density 3%, or you can understand maybe around 3% energy increase. So that's with this new format, we also enlarge our driving range and energy. So we introduce a long range. Yes.
And that was always kind of the problem with LFP. LFP in the past was, okay, a little less energy dense, but then also you could charge it to 100%. Now you're kind of getting the energy density and charging performance in one cell. You also mentioned, I sat through a presentation earlier, how this can be cooled and heated from 6 sides.
Okay, yes. Also, thanks to this special design, the wave, because you see, we have, with this new shape, new format, we have a 6 flat surface. With this flat surface, it could be flexible for fluidable and coolable.
Yeah, absolutely.
If it depends on the customer requirement, it can be customized.
Yeah.
For example, you can ordinarily we put the cooling plate in the
bottom plate cooling. Yep.
Yes. And also, if necessary, if the charging requirement is very high, we need to control temperature better. We can use the thick surface cooling. Also, maybe you can choose also this surface and this two surface. Also, this two surface. So why we call it? It can be coolable E6 surface. And meanwhile, if you want to improve your mechanic performance, like vibration and flat and stiffness, we can also glue this surface, fix this cell.
Oh, nice.
Yes. Also for the side crash, because there is no terminal in this side, so
right. So for crash performance and others, it's pretty good. Speaking of emergency situations, there's also announcement with this cell of no propagation 3.0.
Yes.
And so this seems really impressive to me.
Yes. Yeah, for this product, we integrate our non-propagation 3.0. What does it mean? It's a system solution and also cell chemistry, cell mechanic design, and also the cell chemistry optimization. Due to this several countermeasures, we achieve propagation 3.0.
Yeah, and so the no propagation 3.0 means you can take basically a direct hit from a thermal event in a cell, let's just say, and you can continue driving. It maintains voltage in the battery pack?
If one cell happens some wrong way, so it won't trigger the neighborhood cell. The neighborhood cell can keep in safety temperature. So only one cell will happen some wrong way. And also with our no propagation 3.0, when some wrong way, one cell happens some wrong way condition, the battery system continues to output, can sustain to output the power. So you can imagine two cases. One case is in German autobahn. You're driving a car with in 200 kilometers per
or
hour.
300. Today I did 330 this morning. Crazy.
Wow, amazing.
Really fast one. It was awesome.
So if one cell happens some wrong way, currently without this solution, currently the system will detect this and will shut down.
Just shut down. It does high voltage isolation, close the contactors open, and then you're done on the side of the road or in the middle of the road. Now this isn't common, but with so many millions of cars on the road, everything happens.
Yes.
Yeah.
And also, second one is you can imagine another condition. In near future, we will have a level 3 autonomous driving.
Yes.
You can imagine if one cell happened somewhere wrong way, for normal, for previous solutions, the system will close, the high voltage will close. So because the car is driven by the artificial intelligence,
Yeah.
no human being control that.
That's right.
So it will be disaster. Because
Absolutely.
all the brand, the car,
It's
brand
gone-
will
it's
be
gone.
lost.
Yeah.
Yes, it's gone.
Yep.
Immediately shut
And then
down.
you just go in the path of inertia, essentially. I'm
Yeah.
sure there would be safeguards and other things, but still, it's an interesting scenario to think about.
Yes, it's also a durable, redundant design for
Yes.
for the autonomous driving. Because the system detected there has the some around condition. Yeah, the autonomous system will try to drive the car to the safety area and wait for the help.
Yeah, totally.
Yes.
Well, this is a really cool cell. I can't wait. I hope automakers end up purchasing it so we can drive cars with this cell, because it does everything our viewers want. Highly coolable, lots of power for charging, which we love. Huge durability. What is the claimed durability target? It's 1 million kilometers, 12 years?
Yes, for the lifespan, we can with our product and our chemistry, we can achieve up to 1 million kilometers. Yes.
Yeah.
In, 12 years.
That's pretty impressive.
Yes.
And the cost, is it crazy expensive? Is it reasonable? What's the impression from the automaker side?
I believe it will be reasonable.
Okay,
Yes,
very cool.
Finally, we will introduce to the market.
Yeah.
So it's reasonable. We want to cooperate with Europe OEMs for zero carbon planning. Yes.
Yeah. So start tagging your favorite automakers in this video and say, hey, let's go with this thing. Really appreciate your time and your expertise. I know you've been talking to everyone the last few days, but this cell really is cool. And, you know, in the auto industry, when someone chooses to integrate this in a car, it's still a few years of development down the way till it gets the roads. But this is the tech that we will be driving in just a few years' time.
Yes.
So very cool to see all of this. Thank you again for the time.
Thank you.
And we're going to continue along with CATL to learn about battery recycling and more. As part of this visit to the CATL booth, I'm learning about battery recycling and how much you can actually pull out of existing battery cells. So let's pretend this cell has reached end of usable life. And I think end of usable life is more than just the end of usability for that particular cell. A lot of times automakers are not going to put used cells in cars. There's also a lot of applications for second life cells, for stationary storage, et cetera, but it's really hard for new companies or companies to sell someone a product with used battery cells in it in general. So it's actually becoming a much more common practice to recycle the initial battery that was used and use these materials to a brand new battery with 100% capacity from day one. So I'm going to place this CATL cell here in the recycling process. It's now going through battery disassembly. Take a look at this. Physical discharge to 0%. They then churn it up and crush everything, and it flows into this whole process. This is really cool. Separation process. I really want to go to a battery recycling facility. It turns into 1.8 kilograms of black mass, which then comes up here and it dissolves black mass with sulfuric acid. I'm not saying that right. They have directional recycling technology. They separate out all of these individual items here. And of course you have a nickel, cobalt, and manganese lithium metals that come through this self-developed 200-meter ultra-long kiln. That's kind of saying the same thing, ultra-long and 200 meters, but we'll let that slide. Then it comes over here where you have the cathode material that gets placed into new reborn cells, and then the waste material comes out of wastewater ammonia that's recycled for production, CO2 captured for lithium carbonate, emissions treated before release, of course, and then of course solid waste. This is the parts that's left over that can be turned into a ceramic, such as an art piece, which is really cool. Now, some cool stats for you. Like I mentioned earlier on, 99.6% of the metal recovery rate of nickel, cobalt, and manganese. That's an insane, that's almost everything. So almost no leftover. And almost 94% recovery of lithium as well. So that's why it almost makes more sense at times to recycle the initial battery to make a new one than it is to, I think there's always going to be a DIY secondhand battery cell market, but in general, this battery recycling is going to be such a huge component of batteries going forwards. CATL also initiated the Global Energy Circulatory Commitment to accelerate the battery circular economy. So we've already gone through the recycling process, but they've done a lot with the Ellen MacArthur Foundation, which is, I believe, the first Chinese battery maker to initiate a round-trip coalition, which is really cool. And basically, you know, you have to get the right partners involved in order to do a recycling process like that. So that's where they have this. They have to go through and basically capture the data through everything. So this is basically the round-trip CO2 emissions, everything of the cells, from mining to refinery to blah, 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 all the way to the end user and beyond, all the way to recycling. So truly the entire round trip of the battery cell needs to be measured. It needs to be followed through. So CATL is logging everything. They're QR coding things. They're doing a bunch in the back end system to make sure they log what happens with the entire life cycle. I would love to do a dedicated video just on this. I really want to go through and look at what does it actually take to make a cell all the way to recycling and how much can you truly get out. And then you, of course, have the data. So they want to achieve carbon neutrality in its core operations by 2025. This just comes down to all of the factories to make the round trip efficiency much more efficient. And so here you have the carbon emission intensity decreasing, the zero carbon power increasing, and overall the progress of carbon reduction in the supply chain is getting much better as well. All of this is videos. We can make 50 videos on all of this topic, but one thing we don't cover enough on this channel truly is battery recycling, and it's going to become a bigger deal in the near future, and also a bigger deal to encourage cars that go to scrap yards or that in accidents to make sure those batteries are removed out of the vehicles properly and gone through the recycling process so that you can go and make new batteries. So in general, that sort of sums up our entire visit here to the CATL booth at the IAA Motor Show in Munich. That Shenxing battery rips. I am so excited to find a car with that in there, charging at insane speeds. Of course, these things take time. This battery was just released. Automakers can now bid. CATL can bid to automakers to try to get this bought in, this cell bought into actual series production OE cars. Then they're going to hit the road. But the development process takes a while. It's probably a few years away from seeing this battery actually being charged on Out of Spec, but that's a lot closer than I was imagining. So thanks to CATL for having us out here to showcase their booth on the Out of Spec Dave YouTube channel. I promise you'll get back to Dave later on and you won't have to deal with me on here anymore. Thanks so much for watching. See you on another one again soon. Bye-bye.